7:30.
Yep.
Right, I better click to go it. Right, right. Good evening, everyone, and welcome to another CAS webinar. Tonight we have space news from Roy Bryce. Then our main speaker for this evening is Mary McIntyre, whose presentation is entitled Constellations from Mythology to Modern Day. Our next webinar is on the 22nd of November, when our speaker will be Bob Bauer, whose presentation is entitled American Star Parties, et al. Now, I would also like to congratulate Catherine Rayner Evans, who has been awarded the Madeleine Cox Prize from the Society for the History of Astronomy for her astronomy and philately work. And also congratulations go to Mary on her recent award from the BAA of the Sir Patrick Moore Medal for her outreach work. Now it's over to Roy for space news.
Thank you. Just the usual second or two while I get this to work. Okay, hopefully you've got the screen up now. So, exoplanet hunters found thousands of planets, most orbiting close to their host stars, but relatively few alien worlds have been detected that float freely through the galaxy as so-called rogue planets, not bound to any star. Many astronomers believe that these planets are more common than we know, but their planet-finding techniques haven't been up to the task of locating them. Most exoplanets discovered to date were found because they produce slight dips in the observed light of the host stars. Could you mute yourself if you're... Could you mute yourself, please? Various folk, Bob, Neville. Sorry. Most exoplanets discovered to date were found because they produce slight dips in the observed light of the host stars as they pass across the star's disk from our viewpoint. These events are called transits. I'm going to take somebody else once in. Hey, Peter, could you mute yourself, please? Peter Barr. Yeah, could you mute yourself, please? We can all hear you coughing.
Can I make myself come again?
Can you mute yourself? Can you switch your microphone off, please?
Oh, I could do that. All right. Yes.
Yeah.
Hang on.
Let's see that or just be quiet. Down on the bottom left of your screen should be the icon for it. It's okay, I'll do it for you. I've done it, it's okay. Right. Peter, you don't need to worry about it, I've done it for you. NASA's Nancy Grace Roman Space Telescope will conduct a survey to discover many more exoplanets using powerful techniques available to a wide-field telescope. The stars in our Milky Way galaxy move, and Chant's alignments can help us find rogue planets. When a free-floating planet aligns precisely with a distant star, this can cause the star to brighten. During such events, the planet's gravity acts as a lens that briefly magnifies the background star's light. While Roman may find rogue planets throughout this technique, called gravitational microlensing, there's one drawback. The distance to the lensing planet is poorly known. Goddard scientist Dr. Richard K. Barry is developing a mission concept called the Contemporaneous Lensing Parallax in Autonomous Transient Assay, which happily enough works out as Cleopatra, to exploit parallax effects to calculate these distances. Parallax is the apparent shift in the position of foreground objects as seen by observers in slightly different locations. Our brains exploit the slightly different views of our eyes so that we can see depth as well. Astronomers in the 19th century first established the distances to nearby stars using the same effect, measuring how their position shifted relative to background stars in photographs taken when the Earth was on opposite sides of its orbit. It works a little differently with microlensing, where the apparent alignment of the planet and distant background star greatly depends on the observer's position. In this case, two well-separated observers, each equipped with a precise clock, would witness the same microlensing event at slightly different times. The time delay between the two detections allows scientists to determine the planet's distance. To maximize the parallax effect, Cleopatra would hitch a ride on a Mars-bound mission that launches round about the same time as the Roman telescope, currently scheduled for late 2025. That would place it in its own orbit around the Sun that would achieve a sufficient distance from Earth to effectively measure the microlensing parallax signal and fill in this missing information. The Cleopatra concept would also support prime focus infrared microlensing experiment, just called PRIME, a ground-based telescope currently being outfitted with a camera using 4 detectors developed by the Roman mission. Mass estimates for microlensing planets detected by both Roman and PRIME were significantly improved by simultaneous parallax observations provided by Cleopatra. Cleopatra would be a great distance from a principal observatory, either Roman or another telescope on Earth. The parallax signal should then permit us to calculate quite precise masses for these objects, thereby increasing the scientific return. NASA is preparing to launch its first ever planetary defense mission to crash a spacecraft into an asteroid to slightly change its course. Engineers and scientists who are part of the American Space Agency's Double Asteroid Redirection Test, or DART, team have filled the spacecraft with fuel, performed many of the final tests, and are running rehearsals as they approach the scheduled launch date of 23rd November. Lindsay Johnson, NASA's Planetary Defense Officer, said in a statement that DART will be the first demonstration of the kinetic impactor technique, in which a spacecraft deliberately collides with a known asteroid at high speed to change the asteroid's motion in space. In the mission, the spacecraft is set to ram into the small moonlet asteroid Dimorphos, which orbits a larger companion asteroid called Didymus, at about 6 kilometers per second to slightly change its orbit. Researchers then hope to use Earth-based telescopes to measure the effects of the impact on the whole asteroid system. Didymus is nearly 780 meters in diameter, or about the height of Burj Khalifa skyscraper in Dubai, which I went up above the clouds and got no view whatsoever for 60 quid. Its moonlet Dimorphos is about 160 meters in diameter, or about the size of the London Eye. At the planned time of impact, the asteroid system would be about 11 million kilometers away from Earth. It's my favorite subject, Mars. There's many types of rocket fuel. Some are more useful on a particular planet, and some can be created by bacteria. A team from Georgia Tech has found a rocket fuel with an interesting mix of these characteristics that might be a focal point of in-situ resource utilization on Mars. 2,3-butanedienol might not be a household name like methane, which is commonly used as a rocket fuel on Earth. It's primarily used in the manufacture of rubber products, but it does quite a punch when it's burned with liquid oxygen. Enough of a punch to be able to lift a spaceship into orbit on the red planet. What's more, 2,3-butanediol is relatively easy to synthesize. All that's needed are some bioreactors and some CO2. The bioreactors, which are the size of 4 football fields in the proposal described by the GT team, hold a multi-stage process that starts with cyanobacteria, also just known as algae. Cyanobacteria would photosynthesize as part of their natural life cycle, absorbing CO2 out of the Martian air. After the algae does its work, it's introduced to enzymes that break it down into complex sugar molecules. These sugars are then fed to another bacteria, E. coli, a favorite of biology students everywhere. Feasting on the sugars of the dead cyanobacteria, E. coli produces 2,3-butanediol, which is, as we said, a type of rocket fuel, which must then be separated from the general soup of the bioreactor. At the end of the process, there's a propellant that can react with an oxidizer. Fortunately, this process also creates pure oxygen as a byproduct, as one of the steps. So a single process can pull CO2 from Mars's atmosphere and make both the oxidizer and propellant needed for rocket fuel. Traditional rocket propellant, such as methane, must be shipped from Earth if it's to be used in remote locations like Mars. Costs for these shipments could reach billions of dollars for the amount of rocket fuel required to lift a human-loaded ship back off Mars. So why hasn't 2,3-butanediol been offered up as a solution to this expensive rocket fuel creation problem before? Well, partially because it isn't particularly good, on the Earth at least. Mars has a much smaller gravity well, making it possible for fuels with less power behind them to launch a rocket into orbit effectively. In addition, the lack of oxygen in the atmosphere makes 2,3-butanediol a much more attractive choice for propellant. While this sounds like an idealized process for creating a valuable resource out of literally thin air on another planet, some hiccups have to be overcome first. The first is whether the actual cyanobacteria and E. coli can live in the Martian environment. Its harsh atmosphere and constant radiation bath can quickly debilitate living organisms, and it would likely be prohibitively expensive to enclose the rocket fuel farm in an environmental dome. So for the process to work, these hardy bacteria will have to be able to operate in the open Martian atmosphere. Frameworks are a valuable tool in science. They give context to sometimes abstract concepts such as how powerful can an alien civilization be, known as the Kardashev scale, or how developed is this technology residence levels. Now NASA has developed a new scale to help give context to what some consider one of the agency's most critical missions, the search for extraterrestrial life. So why is a framework needed for this particular concept? Well, NASA's cautious about how they and their funded researchers announce anything that might pertain to the detection of life on other worlds. The famously inconclusive Mars lander experiments announced by Bill Clinton are an excellent example as to why. In the media circus around the relatively recent discovery of what appeared to be phosphine gas in the clouds of Venus drove rampant speculation until the results appeared to be overturned by further research. There's also a lot of nuances in the way life can be detected. Some are more significant than others, and that's what NASA uses as a base work for this framework. How important a particular discovery is, ranging from, that's a bit weird, to, hey, there's definitely some biological process going on here. The scale, known as the confidence of life detection or cold scale, ranges from 1 to 7, with 1 being the least significant and 7 the most. In other words, 1 is the, that's weird bit. In NASA's press release, they give the example of the presence of biologically relevant molecule. Future explorations on Mars could turn up just such a molecule, but it's hardly a smoking gun for the presence of life, as organic molecules are abundant even on comets and asteroids. At level 2, the scientists would start eliminating potential contamination, specifically whether anything influences the data came from Earth. Biological molecules have previously attached themselves to spacecraft, despite scientists and engineers' best clean room assembly and testing efforts. Level 3 continues this theme of elimination over potential causes. To reach this level, scientists would have to present a reasonable explanation for the molecule's presence. It's much harder to determine whether some previously unknown inorganic process might have formed the molecule without that. And that's exactly what level 4 is supposed to expand on. It can be tricky to prove a negative, but level 4 should eliminate all the other sources to the potential biosignature, or at least prove they're implausible in that environment, according to the Nature paper outlining the framework. As with all good science, any finding should be validated by other researchers. So to reach level 5, an independent team must confirm the finding seen in the first place. And also, in a nod to the phosphine episode from last year, level 6 is only reached when alternative hypotheses offered to explain the biosignature haven't panned out. This all leads to level 7, when scientists predict that some other potential signal that could be created by the life behind the biosignature and conclusively detected, with at least 2 different pieces of evidence pointing to a biological explanation for a phenomenon, NASA thinks scientists will have reached the burden of proof to definitively announce they've detected life on another world. The same scientists, oh, sorry, somebody else wants in, I've just got to let them in first. The same scientists that developed this framework have also asked for feedback, including changes to the framework itself. They view it as part of the conceptual mind shift that their work is supposed to engender, and their timing couldn't be better. Not only are there several upcoming missions dedicated to finding life in the solar system, such as Europa Clipper and Dragonfly, but large space observatories such as the James Webb Space Telescope could find the types of biosignatures the framework is supposed to contextualize on planets outside our solar system. Hopefully, the media can use this scale to help temper expectations of the news of biosignatures in the future. But dealing with emotions when discussing potential answers to one of the most asked questions in history is complicated. If used correctly, the cold scale can help lay people and scientists alike to know that if or when it's time to get truly excited about finding life in another world. Yeah, because I let somebody in. I've lost focus on the screen. It takes a second. Got it. Titan has become a centre of increasing attention as of late. Discoveries from Cassini have only increased interest in the solar system's second largest moon. Liquid on its surface has already prompted one upcoming mission, the Dragonfly drone NASA plans to launch in the mid-2030s. Now a team of dozens of scientists has put their names behind a proposal to ESA for a similar mission. This one's called Poseidon, and it would specialise in exploring some of Titan's methane lakes. Neither mission will be the first time Titan's surface has been visited, though. That distinction belongs to Huygens, a lander launched with the Cassini probe. Unfortunately, with the relatively limited technology of a probe launched in the late 1990s, it was only able to send data back from the surface for about an hour and a half. Both Dragonfly and Poseidon have much longer mission timelines planned. Poseidon itself would comprise at least 2 separate vehicles, one orbiter that would allow consistent close monitoring of the moon, and at least one lander that would both collect atmospheric data on its way down and hydrological data from the lakes that would be its primary target. Another potential idea is to have a swarm of landers that would allow multiple data collection missions simultaneously, but would require significant advances in swarm technology that might be on the horizon before the mission's launch date. No matter what configuration of probes it ends up with, Poseidon will have 3 particular mission goals for its time on the shrouded moon: to understand its atmosphere, its geology, and its habitability. At this early stage of development, the mission payloads up in the air, but various instruments could answer a variety of different questions. An instrument the team stressed would have to be included was a more powerful mass spectrometer. Cassini's mass spectrometer hit its limit when it found large ions in the upper atmosphere, so most of the composition remains unknown. With a more powerful instrument, more of that composition would become clear. Since Titan also has seasons, a more extended mission would allow scientists to potentially collect atmospheric data for a whole season, giving finer detail to Titan's dynamic changes. However, the atmosphere obscures the moon's surface, making it challenging to observe Titan's geology from Earth. Having a nearby orbiter would therefore give plenty of advantages in understanding the makeup of the moon itself. The most crucial instrument for understanding Titan's geology, the second of the mission goals, is a ground-penetrating radar attached to an orbiter. On Earth, the technology is used to map utility lines or cut structural concrete pylons, etc. While in space exploration, it helps scientists map out potential areas of interest. Some of these areas of interest might be harboring something even more exciting: life again. Titan is one of the few places in the solar system that might be potentially habitable, thanks to its standing liquid lakes. There's a lot unknown about its ability to harbour anything as complicated as a biosphere, and Poseidon hopes to start filling in those unknowns. The best way to collect data to fill in these unknowns is to collect a direct sample from Titan's surface. This is best done by a drone using a spectrometer similar to the one required for atmospheric observations, and named Cosmo Orbitrap in the white paper. Additional evidence for life, such as chirality, could be collected via chiral gas chromatograph. Whatever the eventual, oops, I moved too fast. Whatever the eventual payload and configuration, there's still a long way to go before anything gets off the ground. This also isn't the first time such a mission has been proposed to ESA either. Some format has been floating around the agency since the early 2000s. With the specific deadlines getting closer, the project might be getting to make or break point soon. Currently, the project plans suggest a launch in the early 2030s, arriving on Titan before the moon's spring equinox in the Northern Hemisphere on the 22nd of January 2039. Dragonfly, NASA's drone mission to Titan, will land slightly before then and provide valuable data to the mission planners before their final approach. While the orbiter component Poseidon will remain in orbit around the planet, the lander will likely touch down in the Northern Hemisphere near an extensive series of lakes. Dragonfly, which will focus more on the equatorial regions, could collect data from a very different climate and potentially also geologic perspective. All this effort and planning will come to nothing if the project isn't funded. The white paper was submitted in response to one of the objectives of the ESA Voyage 250 mission, themes being defined as moons of the great planets. Titan's one of the most interesting, but still a long way to go before any ESA mission touches down or orbits the moon again. Something going a bit funny with this. The Hubble Space Telescope, which has been operating in space since 1990 and was last repaired by astronauts in 2009, entered safe mode on October the 25th following a glitch, and currently can't perform any observations. However, all instruments are healthy, as an investigation confirmed and an update on the 2nd of November.
Roy, can I just interrupt there?
Sure.
I run a sort of observing campaign for a comet called 29P,
Right.
and it had its brightest outburst for over 40 years, so I flagged it to the community. And amongst the various observatories, time was applied for on Hubble. So this was discretionary time where it's the director is able to slot you in, although you didn't plan it originally. Well, they slotted in a couple of orbits to image 29P, and the images were going to be taken on October the 26th.
No.
The day after it went into safe mode.
Oh gosh.
We're all
get
twisted.
those slots back, will you? That's a shame.
It's too late now because yeah,
it's past. Anyway, just got another minute or so for this to go. The recovery team is now examining hardware that commands the instruments. NASA stated that the team is analysing the circuitry of the control unit, which generates synchronization messages and passes them to the instruments. The agency is considering changing the instrument flight software to allow it to search for data synchronization messages, without falling into safe mode, since the loss of these messages appears to have been the reason for the glitch. The telescope isn't intended to be surfaced in person again, as the set of space shuttles that used to fly periodically to the telescope for repairs were retired in 2011, after the program had its 30 years of operations. Investigators are thus working to help Hubble at a distance. Workarounds would first be verified using ground simulators to ensure their work is planned, NASA said. The software changes, if they happen at all, will happen once the Hubble team looks at the control unit design diagrams, data from the lost messages, and the range of potential instrument software changes that could address the problem. Parallel to this rescue effort, Hubble team members are trying to collect data from the observatory's cameras and instruments. During the weekend of October the 30th, the team turned on parts of the near-infrared camera and multi-object spectrometer, or NICMOS instrument, and that allowed the team to determine how frequently the data synchronization problem occurs. NICMOS was recovered on Monday, November the 1st, and since then, no further data synchronization messages were lost, the update said. Next, Hubble engineers have been working to recover Hubble's Advanced Camera for Surveys, or ACS instrument, with an aim to begin gathering science again after the beginning of next week. The final decision will come on Sunday, November the 7th, or yesterday, and I haven't managed to get an update after that. ACS was selected as the best instrument to try first, as it's the least likely to induce stress on the rest of the observatory, NASA said. If a lost message is seen before then, the decision to activate ACS will also be revisited, NASA said, stating that the plan to return the instrument for full service is still evolving. The team's proceeding cautiously to ensure the safety of the instruments and to avoid additional stresses on the hardware. So, that was a bit longer than it was meant to be. Sorry about that. I never bothered timing it. I was out all day today. Anyway, so as ever, thanks very much to the Universe Today podcast people for the newsletter that gives me the up-to-date information to compile this space news presentation. That's the space news for tonight. So back to Alice Amanda.
Right. Right. Thank you for that, Roy. That was really interesting, as always. Yes, there's a lot of information.
I didn't read it all too fast.
Yeah. No, it was perfect. No,
Good.
Really good. Yeah. Yeah, I really enjoyed that.
I
Right.
did my usual trying to find stuff that people didn't know too much about, but
Aye,
sometimes
'cause
that
I'd
media,
never-
you also find stuff that people aren't interested in. It's a bit of a gamble.
Because that was interesting about the gravitational lensing, the micro lensing thing,
Oh,
and
I
that.
hadn't heard
You
of
know,
that
'cause I
before.
didn't know about that.
Yeah.
You know, so that's interesting.
Okay, I'll keep
Yeah.
quiet.
Right. Okay. Mary is a keen astrophotographer and has had her images appear in astronomy magazines, astronomy books, local and national newspapers, and on various TV shows. She enjoys writing and has had articles appear in the BBC Sky at Night and All About Space magazines, as well as a couple of books. She has made numerous appearances on BBC Radio Oxford talking about various astronomy events. In March 2018, she was elected as a Fellow of the Royal Astronomical Society. She's also a member of the BAA, the Society for Popular Astronomy, and the Society for the History of Astronomy. When not doing astronomy-related activities, she enjoys other types of photography and microscopy. She also plays bass guitar and sings with local musicians. She loves arts and crafts as well as baking, and she creates special effects, props, and makeup looks for Halloween, her favourite time of the year. So let's give Mary our usual warm Kaz welcome.
Thank you. Yeah, Halloween certainly was different this year on account of us experiencing the tornado, but I'm not here to talk about that, so I'll just share my screen. I'm so glad you've chosen this talk because it was one of the most fun to put together in many ways. And in this book, I'm going to cover some of the Greek mythology, but also some of the other mythologies that you might not be aware of, mostly because I don't really like the Greek ones, to be honest. I just think that the stories are a bit grim in a lot of cases. The first thing I ever observed when I was a child was the moon, because my mum used to point it out to me, being a child of the Apollo era and stuff like that. But astronomy really came alive for me thanks to this book. And this book was in my class. We had like a little mini library in our classroom when I was at junior school, and this book was in it. And reading this book, looking at the star maps, looking at the imagery surrounding the myths and legends really brought the sky to life for me. So you can imagine how excited I was when I found this book on eBay a few years ago, and I genuinely cried when I read through it because this book was so special to me and is kind of where it all started for me. So I'm going to go through some of the stuff you may or may not know about the mythology, but I'm also going to talk about constellations in the context of the modern day and some of the things that we've observed within them. So I'll try and cram quite a lot into the hour. First of all, early humans, as we would recognize them as humans, evolved about 200,000 years ago. And we know that ever since humans were kind of able to record things, that human as a race have actually studied the night sky. As far as I know, the oldest recording of the night sky still remains this cave painting in Lascaux in southern France, which dates back to about 17,300 years ago. I think they thought they found another one, but I'm not sure if I've seen verification on it. But this cave painting is just basically a series of bulls in different positions. And obviously, bulls would have been very important to these people. And same with mythology stories. Whenever you talk to people about what's important to them, that is what they're going to assign to the star patterns. Somebody actually realized that you can superimpose a map of where the stars were at that time, and it perfectly fits with this cave painting. And this has been verified. It's kind of believed to be true. So we know that people were observing the night sky and thought enough about it to actually record it all that time ago. As well as cave paintings, we have rock carvings called petroglyphs, and these are basically dotted around desert areas all over the world. And you can just kind of wander around the desert and just find them. And they're just amazing. And I saw a talk by Gary Fields a number of years ago now. And he was talking about going to the Atacama Desert in search of the most perfect skies. And he talked about how emotional he felt when he saw some of these rock carvings. Some of these rock carvings are also thought to be depicting night sky events. And this one from Arizona is about 5,000 years old. And you may recognize this already, but basically the swirly thing here is thought to be the Pleiades. This is Orion, because the stars of Orion can form across. They don't have to make the shape that we do. And yeah, just basically all of these different stars in the Milky Way are thought to have been carved on this rock. And how amazing is that somebody did that and we can just go and find it lying around in a desert. And this one is not quite so old, but it's depicting the supernova in Scorpius that occurred in 1006. And I just think these are so unbelievably beautiful. So we know that kind of looking at the shapes of things and new stars appearing and stuff like that has been recorded since the dawn of time, essentially. We also have a lot of calendars, and they're obviously not in the form that we use today, but they might be strategically placed pieces of rock or cutouts on the slope of the side of a hill. I know there's a Mayan calendar that the sun is in a particular position that lines up in the gaps once a month and stuff like that. So there are loads and loads of these dotted all over the globe. The oldest are thought to have been built around 10,000 BC. And I say that there could be a 2-hour talk just talking about calendars. But as well as calendars, we have stone circles, and these are harder to date, but as well as stone circles, there are wood circles that we found evidence of. These are probably around about 7,000 BC that they were built, and they are all over the world, but there are over 1,000 examples that still survive just within the British Isles. So somebody really loved stone circles and built a lot of them. They are attuned to the solstices. That's about all we really know of them. I am no expert on stone circles, but I can guarantee you the majority of the people that go to Stonehenge on the solstice have no actual clue why they're there. They just kind of go there because people do. And there is so much stuff. I believe there was a program on TV just recently about this, and a lot of the conclusions they came to were just an utter bilge. So there's a lot of really bad information about stone circles. But no, I've seen Stonehenge from a distance, and somebody cared enough to transport those rocks from South Wales to Wiltshire to build this thing, and it's huge. It's absolutely amazing. It's not something you can just pick up and take with you. Equally, there's the Rollright stones not far from where I live, and there is something very special about visiting one of these, even though I don't know why it was built. So there is something just amazing about it. And that brings me on to the fact that obviously you can't pick up a stone circle and take it with you, neither can you pick up a cave painting. This is the Nebra Sky Disc, and it's been in the news again recently because it's going to be on show at the British Museum, I think it is, or the Science Museum. Either way, it's going to be in London from February onwards, and I definitely want to go and see it because I think this thing is absolutely beautiful. This was actually found by metal detectorists that were basically robbing a cave, and they didn't realize what they'd found at all, and in the end they did give it up. And it's thought to be one of the most important discoveries of the 20th century because it is the first kind of thing in existence we found that is a portable tool for measuring the sky. And these notches around the outside probably have some significance. This is thought to be the Pleiades, probably a full moon, crescent moon, the arch of the Milky Way. The people that have studied this have found a lot of kind of parallels with the night sky. And it also can measure the yearly position of the sun. So it's been really, really important, especially because we didn't have Google calendars back then. People needed to grow crops. They needed to know when to harvest stuff, when to plant stuff. So at the very least, to grow food, you would have needed something like this. But also a lot of religions, there was a lot of significance placed on the positions of celestial bodies. I really want to go and see this. I think it's beautiful. Another amazing thing is the Anti-Fakir Mechanism. This was in the news again recently as well. This dates back to around about between 150 and 100 BC, and it is an extraordinarily complex piece of machinery that was kind of like a really complicated planisphere type thing. Really, it had orbits of different things, all of these interlocking cogs. It was just unbelievable. And this is they've done obviously a lot of X-ray scans because it looks like a gnarly piece of rock now, but they've done a lot of kind of research on what they thought this did, and they built this acrylic, obviously see-through plastic model of it to show the complexity of the inside of this. This complexity was not seen again until the 18th century watchmakers. So somebody that built this genuinely must have had so much knowledge that was just so ahead of their time, because to build this thing and make it work was just so difficult. But recently, some researchers at UCL have actually produced, this is a computer generated graphic of what it looked like, and you can see the complexity here. I mean, I don't know all the ins and outs of exactly what every bit of this does, but it's so complicated. And as I said, this sort of complexity just wasn't seen again for a long, long time afterwards. So this is another thing I'd love to see in person, even though it's just a gnarly piece of rock now. It's just amazing. But basically, the take-home message here is that the sky has been important to humankind ever since humans basically evolved as modern humans. Now, the constellations, when we talk about them now, we tend to think of them in the Greek or Roman sort of versions of them. But the Greeks were like one of the last to do it. The earliest constellations were actually named in Mesopotamia, going all the way back to 3500 BC. Most of the cultures named the constellations after different objects. They tend to be stories or objects that are important to that culture, that part of the world, and they broke the sky up differently as well. So the Chinese constellations are completely different from the Greek ones. So I find it really interesting to see how different the different kind of constellation maps are. Egypt named 36 in about 1000 BC. Then we had India doing it. Chinese really love their constellations. A lot of them are very small and named after inanimate objects, and others of them have very beautiful stories tied up, which I'll tell you one of in a moment. But by 400 AD, they'd named 284 constellations, so they've got way more than we do. It wasn't until the 4th century BC that the Greek Roman kind of mythologies came about and the constellations were named. Initially, there were 48 because at that point people were not traveling around the globe, but global travel then obviously meant they mapped the southern hemisphere as well, and there are now 88 that are officially recognized, and those other 48 were added by explorers. So basically you can also get asterisms, which are an informal name of a group of stars, but in terms of officially recognized constellations, we have 88 of them. It can be really difficult for a newcomer to stargazing to actually find the shapes. Orion is fairly obvious, but a lot of the others can be really difficult. And this is an all sky view on Stellarium. The great thing about Stellarium is that you can click a button that draws the lines on for you, and that is amazing. And it can also draw the artwork, which is useful because the majority of these constellations, I don't think, look remotely like the thing that they're named after. And it's very interesting. One of the things I do when I do talks with scouts or in schools is I will give pupils a star pattern and then get them to make up their own story around it. And that is a really fun activity to do. If any of you do outreach with school, just try this, because they will name it after something that's important to them. So basically Orion became Elsa many times over because Disney princesses were important to people, and somebody named one after a PlayStation controller and stuff like that. It's just such a joy to actually do that with kids. So the artwork is very subjective, and there are no two sets of artwork that correspond with each other at all. Sometimes you'll have the artwork with the nose at one end of a constellation, sometimes the nose is at the other end. No way is right or wrong. It's just, that's just how that artist has chosen to represent that thing. And basically when Vulpecula is two stars with one line drawn between them, you've got a bit of artistic license there. Now, when we observe the night sky, obviously it looks like the sky is rotating, and the pole star stays static for us in the Northern Hemisphere. There isn't a south celestial pole star, but in the Northern Hemisphere we have that. And a lot of the stories within the mythologies are actually related to the relative positions of the stars, and also the movement and how frequently something may appear. And I think it's so beautiful when that has been taken into account, and I'll point that out wherever I find it as well. Of course, what we're doing there is seeing the rotation of Earth, not of the stars, but it does look like the stars are moving. And I had to include this because this picture was like one of the biggest labors of love I've ever undertaken. But earlier this year, I finally completed my 24-hour full circle star trails. Part of me wants to do it again and do it better. Part of me is like, don't do that again. And if you do ever try this, don't put a tree in the foreground that grows, because they grow and they move. Absolute nightmare. But if you watch on a time lapse, this is a 10-hour, 35-minute time lapse, you can see the pole star does move because it's not perfectly aligned at the pole. And of course, that pole star hasn't always been at the pole either, because the Earth wobbles on its axis. It's about every 22,000 years, the precession means that the exact star above the celestial pole will move. But for us within our lifetime, it doesn't really move. So once you know where Polaris is, you've got it forever. And of course, as astronomers, we already know that that is not a full 24 hours. It's just under 4 minutes less each day. But that means the stars rise 4 minutes earlier every day. And that difference doesn't show up on a day-to-day basis, but it's why we have different constellations in the southern sky, at least, in different seasons of the year. Now, Ursa Major is probably one of the constellations people think they know because of the plough. People think the plough is the big bear, but it isn't. The plough is just these 7 stars. And it can be pretty hard to actually find it on a long exposure photograph on a dark night. The moon can actually help you with this because the moon bleaches all the faint ones away. So that is the rest of the constellation. The plough is visible every night of the year from the Northern Hemisphere. The lower bits here get lost at certain times of year. But the interesting thing is that within our lifetime, these stars don't really move that much. There's the odd one that has a really obvious proper motion over a number of years, but within our lifetime, they don't move a great deal. You can use those stars to find Polaris, of course, but the stars within the plough looked completely different 100,000 years ago, and they will look completely different 100,000 years in the future. So although this is a long time frame and not as long ago as when the constellations were formed, I kind of give the Greeks a bit of leeway because maybe some of the stars are in a different position, and that's why we don't think it looks like anything that they've named it after now. This looks more like a plough than it does now, to be honest, but you can see those stars are definitely moving relative to each other, and it's really interesting to just see that for different star groupings as well. Now, the first mythology I'm going to talk about is Ursa Major, and this is the first example, as you can see, where the artwork on my beautiful ladybird book has got the nose of the bear on the handle of the plough, but on the Stellarium one, that's the tail. Either one works fine, but being the tail fits in with a different mythology that I once read. Now, I don't work from scripts when I do talks, but I have a real problem remembering all of the Greek names. If you see me looking down, it's just so that I've got the prompts for the names of these different characters. Otherwise, I'm going to tell you the wrong thing. But the Roman mythology The story here is around Jupiter, who is the king of the gods, and he lusts after this absolutely beautiful maiden called Callisto. Now, Jupiter's wife discovers that Callisto has a son called Arcus, and she is convinced that Jupiter is the father of that child. And basically, because she's so jealous, she turns Callisto into a bear so that therefore her husband won't be tempted to stray away anymore. But there was almost an absolute catastrophe, because Arcus was then walking through the woods and encountered his mum in bear form, and he made to get his arrow out ready to shoot the bear. Obviously he feared for his life, and to kind of avert the tragedy, Jupiter then turned Arcus into a bear as well. So basically neither of them got killed, but they then both got placed up into the sky, and where they form Ursa Major and Ursa Minor, the minor one being the sun. Do you know, I can still to this day, I'm nearly 50 years old, whenever I look at Ursa Minor, that is that little face that I see coming back at me. It's just so beautiful. And I honestly felt so emotional the first time I saw this little constellation naked eye for the first time. Now, the Aztec mythology is fantastic. It's a character called Tezcatlipoca, and I'm going to call him Tez because that's actually a really difficult word to say. But basically, there were two brothers. Like the god Quetzalcoatl was a really kind and helpful god, and he taught his people many virtues and lots of skills, and he was a really good god. His brother was Tez, and Tez was a strife monger and a sorcerer and a magician, and he caused all kinds of trouble for humankind. And one of the things that he used to do was disguise himself as a jaguar. And in one occasion, he ended up losing a leg when an enemy slammed a door on his leg when he was in jaguar form. So he then had a wooden leg. And Quetzalcoatl got really annoyed with his antics, and basically, to save humankind from any more of his trouble, basically permanently turned him into a jaguar and placed him up in the sky where he couldn't cause any more trouble. And there he's forced to hop around the pole on his wooden leg. I love the fact that when you look at the stars in this grouping, they do kind of move around in a circular motion, which is kind of what you'd expect to happen if you had a wooden leg. And of course, when I drew this, because there was a wooden leg, I had to give him an eye patch as well, because why not? So I love Tezcatlipoca. I think he's hilarious, and all jaguars should have a wooden leg and an eye patch, I reckon. The other thing I'm going to do when I go through this is talk about the things that I think these stars look like, because it's something that I did the first time I did this with the children. And I think this looks like an aardvark. If you ever do this activity, I hope you do, just try this for yourself. Just look at some star shapes, ignore the lines. You can put the lines wherever you want, as long as you've got the star shape, and just have a think about what it looks like to you. And to me, I think that the Plouse in particular, but some of the other stars of Ursa Major look like a giant aardvark. So there you go. So I'm going to show you my McIntyre mythology interpretations as we go through as well. Now, Cygnus the Swan is still visible, even though we're kind of heading away from the summer months now. It's actually visible well into the autumn and is a really beautiful cross shape. It's one of the few constellations that actually does look like its name does look like a giant swan. So the mythology here is a giant swan. Obviously, the long part there is the long neck of the swan. Now, Cygnus the Swan has got lots of different identities within mythology, and with even the mythology stories I'm telling you now are just one version. There are many, many different versions depending which book you read, but it's most likely that Cygnus was Zeus in disguise. And the first story is actually not one of my favorites. So Leda was the beautiful wife of the Spartan king, and she had unrivaled beauty within her land. And Leda was so beautiful that Zeus couldn't resist her, and he knew that as himself he would never win her love. So he disguised himself as a swan, and the story says eventually won her love, but what actually happened is he brutally raped her, and it was just a really horrific story. And this is where I have a bit of a problem, because why immortalize somebody that has has done something that vile in the sky. I don't like that about the Greek stuff. But there's another Cygnus story that I much prefer, which I think is really nice. And this is about two gods. They were really good friends, but got very competitive with each other. And they were racing their chariots up in space. And they were so focused on the race and who was going to win, and each of them wanting to beat the other one, that they just didn't pay attention to where they were going. And both of them got too close to the sun. And when they did that, their chariots began to melt, and they both, obviously no longer having a chariot, fell back down to earth. One of them kind of landed straight into the river, but the other one had his fall broken by the trees. His friend, who went right to the bottom of the river, couldn't swim, and his friend really wanted to go in and save him, but he couldn't swim either. So he basically prayed to Zeus and asked him to turn him into a swan so that he could dive into the river and save his friend. And Zeus was so moved by the courage that he did turn him into a swan, and he did go in and rescue his friend. And then Zeus was so moved by this bravery that he basically then, when the swan died, Zeus placed him up into the heavens as a reminder of courage and friendship. And I'm more here for the courage and friendship stuff than raping people, I'm afraid. So I much prefer that story. I really like the Chinese mythology of this as well, and that is the story of the Magpie Bridge, which you may have heard of already. And this involves a couple of other stars that you can see here. It involves Vega up here in Lyra, and also Altair down here in Aquila. And basically, if you think of those two stars here, these are two characters in the story, and the Milky Way here is a massive river that separates the two of them. So this is a love story. Xenu was a weaver girl, and she's represented by the star Vega, and Nuilang was a cowherd, and he's represented by the star Altair. Because they were from two completely different classes, their love was forbidden. So they were banished on opposite sides of the Silver River so that they couldn't be together. But once a year, on the 7th day of the 7th lunar month, all the magpies on planet Earth come together and form a massive magpie bridge so that the lovers can have one night a year together. And I think that this picture is better than one I could do. So this is by Warwick Coble, and I think it's such a beautiful representation of these star patterns, because we always think of Cygnus as a cross, but if you do it this way, you've got a flowing dress and all the magpies around them forming the bridge. And that is actually the origin of kind of the Chinese Valentine's Day, if you will. I think it's so beautiful. I really love that story. And since hearing that story, I've got more love for magpies. I've always loved magpies anyway, but whenever I see a magpie, I think of this story. So nice. I'm a huge fan of the Hunger Games. I know the books were not aimed at my age group, but I thought they were fantastic. I thought the films were fantastic, and this to me looks like Katniss Everdeen's longbow. So that's my McIntyre mythology for Cygnus. Now, Orion obviously coming into view at this time of year for us now, starting to be visible and getting higher in our skies. And this is a very beautiful constellation that is one of the easiest to pick out because the stars in there are so bright, and they often display really good color separation between them as well. So in many mythologies, this is depicting a warrior of some kind of hunter or a warrior. There are lots of different stories around Orion, and I'm going to talk to you about a few of those. So Orion within the Greek mythology was the son of the sea god Poseidon, and Orion could basically walk on water thanks to the power given to him by his dad, who was Poseidon. And Orion really abused this power, and he sounds like he was not a nice person, and basically he would walk on water and go from island to island, creating absolute chaos from the sound of it. So his first stop, he went off to the island of Chios, where he got very drunk and attacked Merope, who was the daughter of the ruler, who was Onipion. Now, understandably, Onipion was furious that his daughter had been attacked by this drunken thug, so he blinded Orion and drove him away. Basically, Orion then stumbled off to Lemnos, where Hephaestus, who was a lame smith god, basically had a forge there, and I can never say these words, Hephaestus told his servant Cedilion to guide Orion over to the east. So he carried Orion on his shoulders, and he basically walked over to the east where Helios, the sun god, was able to restore his sight. But rather than just think, oh, I had a lucky escape, he had to go back for vengeance. So he goes back to Chios to punish Enipion. Luckily, the king hid away underground and managed to escape an attack. So instead, he just walked on to Crete, where yet again he went hunting with the goddess Artemis, who is the goddess of the hunt. And in the process of that hunt, Orion claimed that he was going to kill every living beast on Earth. And obviously, Mother Earth was really not happy with this. So she sent a giant scorpion to kill Orion. And Ophiuchus, the serpent bearer, managed to bring him around with an antidote. And so after his death, the scorpion is placed at one side of the sky, which is why we see Scorpius in the summer, Orion on the other side of the sky, which is why we see him in the winter, and halfway between the two of them, we have Ophiuchus. So that's an example of where the positions of the different constellations are kind of tied into the mythologies. I really like the Iroquois mythology, and this is a little sketch that I did to try and represent this story. Now, long ago, there lived an old man who had grown so old and feeble that he couldn't hunt anymore, he couldn't do his chores anymore, and basically he became a burden to his family and became an outcast to everybody in the village. He knew his days on Earth were dwindling, so with great effort, he gets his bundle on his back and starts to trudge up onto the high mountain to climb it, ready to pass to the next world. When he got to the top, he started to sing his death chant, and this was basically him asking for a continuation of a spiritual journey into the next world. And the sound of this singing drifted down into the village. And as the people looked up, they turned their eyes up to the top of the mountain, and they saw the old man rise up and take his place in amongst the stars. It's kind of heartbreaking. I would have let him come and live with me, but there you go. He went off and did this. But once he got there, he assumed a new role, which is a really exciting new role. He gained back all of his strength, and it was his job to carry the sun across the sky in the summer. So if you look on Stellarium at where the sun is in the summer, you'll see that Orion is kind of underneath it, and we obviously can't see Orion because it's in the same place as the sun. So he carries the sun really high, which brings warmth and light, and therefore people can grow food, and basically has this amazing challenge to do over the summer. But as the winter winds start to blow, his strength will dwindle again. So he needed some downtime during the winter to recoup his strength. So he hands that burden on to his son. His son is really lazy and does the least amount of work possible. So when his son is responsible for carrying the sun, he carries it very low, it doesn't get very high, we don't get much light, we don't get much warmth, and basically that is why the winter is dark and cold. Once we get to the spring, he gets his strength back again, and he regains his position carrying the sun throughout the summer, through the summer sky. I think that is such a beautiful story, I really do. I have said an egg timer for this one, but I also have a very tall, thin cookie jar that perfectly matches the profile of Orion, but nobody else has that cookie jar because it's a one of a kind. So I've gone with egg timer because most people will identify with an egg timer than a random handmade cookie jar. So then we move on to Leo. And this is another constellation where we very often see the artwork done back to front. Sometimes this is the mane of the lion's head, and other times the mane is down here and that's his tail, and he's crouched down ready to pounce. So again, no right or wrong here. And obviously this is a lion named Leo, and Leo is one of the earliest recognized constellations. So there is archaeological evidence that the Mesopotamians had a very similar constellation of Leo way back in 4000 BC. So within Greek mythology, Leo is the lion that was killed by Hercules. And I'm going to talk about Hercules in a second, but one of the labors of Hercules was to kill Leo. Now, Leo basically would take women hostages and get them into his cave, and that basically would lure men to come and try to rescue these women that he'd captured. But the lion could not be killed by any weapon possessed by man on Earth at all. And So all the warriors' clubs and spears and swords were absolutely useless, and he just used to kill warrior after warrior who came along to try to rescue these women that were trapped in the cave. But what Hercules did is he realized that he was going to have to do it with his bare hands. So he slipped into the cave and kind of got in there. And then once the lion pounced, he reached up, grabbed him in midair, snapped his spine backwards, and therefore killed the lion with his bare hands, and all the women were then released. So yeah, Zeus commemorated that labor by placing Leo in the sky as well. And there are other mythologies as well that believe in Sumerian mythology. Leo was the monster Hubble, who was killed by Gilgamesh. So the Epic of Gilgamesh is kind of linked in with Leo as well. So yeah, there's lots of interesting, very, very old folklore about that constellation. I had never noticed how much like a mouse this looked until I did this session in a classroom once, and practically every child that was given Leo as a constellation said it was a mouse. And yeah, it really does. The other thing it looks like is a push along car that you put toddlers into. I don't know, I've never had children, I don't know why I see that, but yeah, it's that's what I think it looks like. So moving on to Lyra the Heart, this is just such a beautiful little constellation, and Vega is just such a glowing light in the summer sky that is really beautiful. And as you can see here, this is Altair down here. This was a super long exposure of the Milky Way that I did eons ago. So Lyra in Greek mythology is a harp, and it's one of the few Greek mythology stories that is actually based on an inanimate object rather than a person that's gone off and done horrible things. But it was the first lyre that was ever made, and it was invented by Hermes, not the same people that lose your parcels, but a different Hermes. And he basically made it by hollowing out a tortoise shell. So he cleaned it and then pierced the rim and strung it with 7 strings of cow gut, not for vegans, but yeah, that was the first lyre that was ever made. And basically Hermes used this lyre to get himself out of trouble a few times. So there was one time where he stole a load of Apollo's cattle. So understandably, Apollo was furious and came to have it out with him and demand a return. But when he heard the beautiful music of this lyre, he said he could keep the cattle, and he took the lyre instead. So basically a load of cattle was swapped for this musical instrument. Not so good, can't really eat the musical instrument. But it was also said to be the lyre of the great musician Orpheus, and his story involves venturing into the underworld, and it's one of the most famous Greek stories. So Orpheus was married to a lady called Eurydice, I think that's how you pronounce it, and she died from a snake bite. And Orpheus charmed the king of the underworld and basically begged him to restore his wife to the overworld, if you will. And basically he was forbidden, he agreed to do this, but he was forbidden from turning around and looking at his bride as she was restored from the underworld. When it came to the moment, he couldn't resist, and he looked over his shoulder, and as he did so, she rose up and took her place in the stars and had to go back to the underworld just because he couldn't resist having that last look. So didn't work out well for either of them, really. But in Wales, this is also thought to be the harp of King Arthur or King David's harp, depending which version you write. Within Arab mythology, it's also comes from the Arabic word al-Nasr al-Waki, which can mean either the swooping eagle or vulture, but some Arabs see this as a tortoise or a goose. So a tortoise kind of appears in the story either way. Sometimes that is the actual tortoise, other times the lyre was made of a tortoise shell. So I do not see a tortoise at all when I look at that. Goose maybe if it had longer legs, but the only thing that I can see when I look at this is an AT-AT. So I'm sorry if that spoils Lyra for any of you, but somebody suggested I do an entire Star Wars themed McIntyre mythology, and I think I ought to work on that because that would be fun to do. But it's just an AT-AT. Every time I look at it, it looks like an AT-AT from Star Wars. Now, moving on to Hercules, as I said, he was the son of Zeus and basically was the god of the sky. So this is a fairly faint constellation. The shape of the keystone is what gives it away, but it's hard to pick out against the background stars. And we've got the beautiful Globular Cluster M13 nestled within the constellation. He is upside down in our skies. There is a reason for that, but I can't remember what it is. But basically, he was the son of Zeus, Jupiter, or Jupiter or Zeus, interchangeably the same person, who was the god of the sky and the god of thunder, and he ruled Mount Olympus as the king of the gods. Now, his mother was one of Zeus's lovers, who was a mortal woman, but Zeus took the boy and laid him at the breast of his wife so that he could become immortal, and that wife being the goddess Hera or Juno. And Hercules drank the milk eagerly like any newborn would, and after drinking that milk he then became immortal. And we're going to come back to that story again in a minute with another context. But basically the king gave Hercules 10 tasks to fulfill, known as the Labors of Hercules, and he did them all, but he had help with 2 of them, so they were disqualified, so he had to do 2 extra. So in the end he did 12 labors, one of which was killing Leo the lion, as we saw. Now, the Chinese mythology is really interesting because, as I said, the Chinese have much smaller constellations and they tend to get broken up in a very different way. But in Chinese mythology, the constellation is pretty much split in half, with the southern part and part of Ophiuchus being a celestial market. So a marketplace was very important to the culture, and also basically the line of stars across the middle that extend kind of out here and into Corona Borealis. That is an office. It's a celestial records office, which is where you went to register all the transactions in the market. So again, an inanimate object in a way, but something that was very important to the culture. The northern part of this is said to be a woman's bed, which is thought to be a reference to the emperor's harem. As with all historical stories, wherever women are involved, it tends to be a harem of some kind. But yeah, so Hercules is a really interesting one and is broken up in such a different way that you can't superimpose any other pictures on there. For me, this looks like a raw chicken, and I have not eaten meat for 30 years, but whenever I look at this pattern, all I can see is a raw chicken ready to go in the oven. So sorry if any of you find that offensive, but that's genuinely all I see. You can also change the lines around a little bit and get some kind of celestial octopus, whichever one you prefer, but it's always going to be a raw chicken for me, I'm afraid. Don't know what that says about my brain. Now, as well as constellations, other sort of celestial objects and kind of atmospheric optics and other events also have mythologies associated with them. So I'm going to touch on a couple of those now. And as we saw before, the Milky Way is tied into the story of Hercules' illegitimate son, Jupiter's illegitimate son, Hercules. So basically, this story is grim. As we heard before, Jupiter wanted his son to become immortal, so he laid him at the breast of his wife, even though it was his illegitimate son. And he suckled so vigorously because he was already exhibiting his legendary strength that Hera woke up, and she woke up and saw this baby that wasn't hers feeding at her breast. So obviously she grabbed him and pulled him away with a jerk, and that meant that some breast milk squirted out, and the breast milk basically spread across the entire sky to form the Milky Way. So you're never going to look at a photograph of the Milky Way in quite the same way again. It's absolutely horrific. But there are lots of cultures, obviously, who saw it as a river of stars, which is understandable. The Mongolians saw the Milky Way as a seam, which has been sewn together, where the 2 halves of the sky have been stitched together. The Sumerians saw it as a massive serpent. This is great. The Polynesians saw the Milky Way as a giant cloud-eating shark. That would be so handy in the UK to have one of those. Crazy. Cherokee mythology is amazing as well. This is a winged spirit dog who stole cornmeal, which is amazing. So basically, the Cherokees realized that something or somebody was stealing their cornmeal during the night. So one night they all laid in wait. They had their drums and their musical instruments, and they all led there silently waiting. The winged spirit dog came down, started to steal the cornmeal, and they all leapt up and started banging their drums and hitting their musical instruments and shouting and chanting, scared the winged spirit dog half to death, who then flew off across the sky, leaving a trail of cornmeal behind him as he flew away. So the Milky Way is basically cornmeal. So amazing. The Estonian mythology is Lindu the Bride, and this is another story that ties in. You can imagine this has been written at mid-latitudes. What happened here is there's this beautiful young woman called Lindu who is betrothed to the Northern Lights. It doesn't come very often, but the Northern Lights appeared, completely wooed her. Northern Lights swore that he would come back for her wedding and then never showed again. So you can see here how the Northern Lights has come in from a mid-latitude display following some kind of solar event, and poor Lindu is left waiting for him to come back, and he never does. And her dad was just so heartbroken seeing his daughter just waiting and waiting forever that he ended up placing her up into the sky, and the Milky Way is her wedding veil blowing across the sky as she waits heartbroken for her horrible Northern Lights to come back, which he never did. Also, the Shoshone mythology is another one that involves bears, and this is another beautiful story involving a grizzly bear called Wakin. And basically, Wakin lost a fight and knew that he was banished to the land of the souls, and he had to climb up a big mountain to get to the land of the souls. And obviously, he's not particularly happy about this. He's injured, he's limping, keeps going and going, gets above the tree line, and it starts to snow. So now he's cold as well as limping and ready to die. As he gets nearer the top, he can kind of hear music, and he realizes that maybe the next life isn't as horrible as he thought it was going to be. So he started to run. He got really excited, and he ran so fast that he carried on off the top of the mountain and up into the sky. And as he moved across the sky, all of the snowflakes that had landed on his fleece spread out across the sky, and every snowflake became a star. I think that is so beautiful. I love that story of the Milky Way. Talking of Aurora, we had a brief chat about it before this started. This is the best Aurora that I've ever photographed from Oxfordshire, and it was near Midsummer's Day in June 2015. And on this occasion, most people north of Birmingham couldn't see it because it doesn't get dark enough to see it. This was a truly incredible display. I'm just going to leave this video running while I tell you about some of the mythologies around Aurora. Cree Indians thought that Aurora was part of life's circle, and these were the spirits of departed friends and relatives trying to communicate with them. And lots of mythologies from around the world where you get regular aurora displays see these as spirits, and you can kind of see that because you can see through them. They're quite ethereal, dancing. You can sort of see how that would be interpreted. One thing that I find intriguing about the Inuit and Nunavik tribes is that it involves the sound, and I've heard that really visible bright aurora displays up in the Arctic Circle have a kind of crackling sound associated with them. I've obviously never heard it, but I've heard that that is true. Aurora, according to the Inuit tribes, is the spirits of dead humans playing a ball game using a walrus skull. Now, I've never kicked a skull, I'm just going to say that up front, but you can imagine if you did kick a skull, it would make the sort of cracking sound that you can kind of imagine being associated with an electrical aurora display. The Nunavik Island had a very similar story, but told the other way round. And Aurora for them was walrus spirits playing ball game with the skull of some unfortunate human. Obviously, it's still a skull getting kicked, and it's making the crackling sound. So I'm really intrigued by those stories, and I hope one day I do get to go somewhere where I get an actual audible experience when watching Aurora. One for Richard here, comets. There's obviously lots of stuff within mythology around comets, mostly that they were a bad omen, sometimes they were a good omen, and it's just crazy. Right up until the 16th century, they were considered to be an omen of some kind, and they were very often tied to the deaths of kings or the birth of somebody important or an upcoming catastrophe or a catastrophe that's already passed. And the time gap between the comet being assigned meaning to these events could be years. So this really kind of clutching at straws here a little bit. But they were sometimes thought to be upcoming catastrophes or the birth of a great figure, as I said, but also attacks by heavenly beings, because comets were behaving very differently from everything else that people were seeing at this time. So you can understand why they were freaked out by them. in 44 BC, a comet was linked to the deification of Julius Caesar, and in Norse mythology, they are said to be flakes of the skull of the giant Ymir falling from the sky. So there's all kinds of really interesting things that have been studied around comets. And I have to show the Moang Dewey Silk textbook because this is so beautiful. The Chinese astronomers of ancient times were so knowledgeable. And back then, people didn't know the distances of celestial objects, and we didn't know whether comets had any actual effect on terrestrial events. So what this textbook has done is recorded cometary forms and various disasters that they think were associated with them to see whether a particular shape of comet tail was relating to a flood or an earthquake or whatever natural disaster had befallen them. And this is basically, it was compiled around 300 BC, but with knowledge that had been saved for all the way back as far as 1500 BC. Something else I would love to see in person. I think this is absolutely beautiful, even though we know it's nonsense and comets don't have any actual effect unless they actually hit the Earth. They don't have any effect on our weather systems or natural disasters, but this is still such a beautiful thing to look at. So next time you look at comets, just think back to how much our ancestors have really studied them. Now, meteors, these are some old meteor videos from our old cameras. We've now upgraded them all to Raspberry Pis and they give a way better quality video, but I just haven't had time to put the thing together. But these are still very impressive meteors. Meteor showers were also seen as a bad omen. And within history, we sometimes see them referred to as comet stars, and we think they're talking about meteors there. And comet stars were recorded in the August of 30 BC, which is a portent witnessed after the death of Cleopatra. So this is thought to have been the Perseids meteor shower associated with the death of Cleopatra. Obviously nothing to do with the death of Cleopatra, it's comet debris, as we all know now. But the Perseids have also been connected to the martyrdom of St. Lawrence, and sometimes meteors are said to be the tears of St. Lawrence. So again, lots of superstition and mistrust of these events, and you can understand that because they are pretty impressive to see them now, even though we know exactly what's going on with them. So crepuscular rays, although there's no kind of mythology as such associated with them, I may have touched on this when I did my atmospheric optics talk for you guys, but it's impossible to look at any sort of religious symbolism of angels or saints without these rays coming out from them. And you can see that in days of yore, people would have seen this as an angelic visit because you don't get rays every single day, but they are more prominent on some days than others. I mean, generally, most days you'll see at least some if you've got gaps in the clouds, but you can kind of see if you've got like a punch hole in a cloud and these rays are kind of poking out of it, that it may be interpreted as some kind of visitor from heaven. So you see that a lot. And equally, the Helicon Shine is this thing which is a great time of year to look for this if you've got frost or dew on the ground and the sun has just come up. If you have a long shadow, you get this backscattering effect around the anti-solar point, and that happens to be centered around what your eyeball is seeing, so you will have a halo around your head. And it's really quite cool to see it. My pictures aren't as good as this, but it will always be centered around your eyeball. So if you hold the camera out to the side of you, the halo will then be around the iris of the camera. So when I took pictures of these, my camera was at chest height, so the halo wasn't quite around my head. But if you're going to take a picture of this, put your camera up at eye level, then it will capture what you're actually seeing. But you can see how some people may have been interpreted as being a saint and having a halo because conditions happen to be right. If people were looking the other way, they would see that they too had one, but there you go. And the Brocken spectre as well. And as I think I definitely talked about this in my atmospheric optics talk, but a Brocken spectre is basically a glory but seen from the top of a hill, and it's named because the Brocken is the highest peak in the Harz Mountains and is shrouded by mist 300 days a year. And that means that there are lots of opportunities for seeing this effect. And in Scotland, it's also connected to the Scottish Bigfoot, or the big grey man of Ben Macdui. And this is where people hill walking record hearing groaning and crunching sounds, and then kind of having this big grey spectacle out in front of them. And, you know, I've said before, this is quite creepy to see. I've done an artificial one in the fog with my car headlights, and it is bizarre to see this enormous shadow stretching out in front of you with this kind of halo around your head of different colors. It's amazing. And even though I did mine artificially, it is still quite a thing to see. So you can kind of see with the way that wind plays around in hills and the way that crunching sounds might echo from your footsteps, it would be a terrifying experience, to be honest, even if it happened today, knowing everything about it that we already do. And sundogs as well. I definitely talked about this in my atmospheric optics talk, but this is from the Greek Germanic word meaning beside the sun, and they are generally most often noticed when they're at the sides of the sun like this, when the sun is low. And this has been used to depict the Holy Trinity in the Nuremberg Chronicle. And sometimes, particularly if you're in a ski resort and you've got diamond dust floating around, as well as the sundogs, you can get this kind of cross effect. This is a sun pillar, and this is the fragment of a parhelix circle that extends all the way around the sky. But you get the sign of the cross as well as those brightening mock suns, as they were sometimes called. There is no doubt in my mind whatsoever that this is sundogs being depicted here, and they've been used to depict the Holy Trinity. And I definitely talked about the Battle of Mortimus Cross as well in 1461, where Edward came out with his troops and described it as seeing two glorious suns, each a perfect sun. And the troops thought they were about to march to their deaths, but he turned it around and said, no, this is important, it's good, it's a good omen, we're going to win the battle. And they did. And this affected him so much that he added suns into his coat of arms. So it was really important. And actually it made it into Shakespeare, that event, because it was dazzle mine eyes, or do I see three suns? That is what it's referring to. So there's a lot of stuff around that, but as well within Germanic mythology, Odin was a sky god and he had two loyal dogs, Jerry and Freki. But also around the whole world, there are like Scandinavian cave paintings with twin sun gods and stuff like that. So definitely sundogs have twins and sky gods, and all of that stuff make it into all of those mythologies. And it's all linked in basically to sundogs and other atmospheric optics, which are amazing. I absolutely love atmospheric optics. So that's the mythology stuff done. I'm going to whiz through some interesting things that we might see in the modern day, because I know I'm running out of time. But when we talk about a constellation nowadays, we're not talking about just the bright stars that make the mythological story. We're talking about an entire patch of sky that has been officially broken up in this way. So if you hear of a supernova in Hercules, here, it doesn't have to be anywhere near these stars. It could be right over here, but it's still classed as being in Hercules. So that's what we mean in the modern day when we talk about constellations. And I can't talk about constellations in the modern day without talking about the Hubble Extreme Deep Field, because this is just fantastic. If you take a pin and hold it at arm's length, that is how much sky this is covering. And within that, they found thousands of galaxies. Almost everything in this picture is a galaxy, apart from like the odd foreground star. And it is mind-blowing, and that they pointed it there on purpose because it's a piece of empty sky. You can barely see anything in it. So if there's that many galaxies there, there's a good chance they're everywhere. And just the technical ability that was used to do this. I'm chuffed if I've done 2 nights of imaging and stacked the pictures together, but this is 10 years worth of imaging with a 23-day total exposure time, which is just mind-blowing. But it shows 15,000 galaxies in that tiny, tiny piece of sky. And this is looking so far back that is how those galaxies looked 13.2 billion years ago. That's 8.6 billion years before our solar system was created. So it has taken a long time for the light to get to us to have even seen that picture. And this is where you kind of start doing time travel when you're probing this deep into space. And James Webb is going to go even further back. So hopefully we can expect some amazing things from James Webb. Our sun is 150 million kilometers away, which is 1 astronomical unit, a lot easier to say than 150 million, but still with the sun being that near, if you just go on a 70-mile-an-hour motorway journey, it'd take 150 years to get there. There aren't enough Maltesers in existence to make me sit in a car for 150 years, but even like a standard passenger jetliner going at full speed, it would take 18 years to get there. even if the Apollo spacecraft was built to last for more than 3 days, which it wasn't, that's the fastest manned thing, the crewed spaceflight thing we've ever built, and it would still take 5 months to get to the sun. So it's a really long way away. But after that, the nearest one is the Proxima Centauri system, and that is 40 trillion kilometers away, which is 4.3 light years. So we're talking about such vast differences here, and that's the nearest one. The furthest one away is just so crazy far away. Now remember, 1 light year is 9.4 trillion kilometers, so I'm not going to do the maths there. So if we wanted to travel to Alpha Centauri in the Apollo space probe, which I know we couldn't, but if we could, it would still take 123,000 years. So I think it's really important when we look at exoplanet research, which I'm going to talk about in a minute, I think is one of the most exciting areas of astronomy. People keep talking about Earth 2.0 and Earth 3.0. We are never going to get there within our lifetime, and probably within several generations' lifetime. And if you put, we're talking about generation ships to travel this distance. And so the people that set out on that mission aren't even going to be alive by the time you get there. So there's an ethical quandary here, because the people born on that spaceship are born into a mission that they didn't consent to. So, you know, I think that's a whole other area, but just bear these distances in mind when we talk about exoplanets. The most distant star is 9 billion light years away. It's just crazy. Now, as I mentioned before, stars in a constellation or an asterism, they're not actually related to each other in any way. They are nowhere near each other in space. And one of the Sky at Night DIY articles that I did a while back was to create this model, and I usually have it on my exhibition stand on a turntable. This is to scale. So if you're stood in front of this model, the distance from you to the back of this model is to scale, and it's about 120 light years across. If you look at that side on, you can see that some of these are fairly near each other, but even they are, in terms of distance at least, still a couple of 2, 3, 4 light years away. These are more like 100 light years away from each other, and that's not taking into account how far apart they are side to side. This is just in terms of distance. So it's always worth bearing in mind that the stars within a constellation are actually not related to each other at all. Stars in clusters are, though, and we have open clusters like this is the Owl cluster. It's one of my favorites, and they are loosely gravitationally bound for the most part. You see, when you look at a cluster like this, that stars have lots of different sizes, and that's because they're different magnitudes, and that is determined by how far away they are and how big they are and stuff like that. So this is a logarithmic scale, which is why sometimes the difference between mag -1 and -4 doesn't seem like a big enough number, but the reality is it's 100 times brighter because it's 2.5 for each of those magnitudes. Commonly, children think Polaris is the brightest star in the sky, and it just isn't. It's really hard to see, but that's about mag 2. And Venus goes down to about mag 4. Sirius, the brightest star in the northern hemisphere, mag -1.5. A full moon -13, and the sun -27. So those numbers don't feel like they're big enough when you think of the difference between them, but it is logarithmic, as I said. Now, stars are bound together by gravity, and there are two sorts of cluster. We have the open clusters and globulars. Open clusters like the double cluster in Perseus, another favorite, and the Owl cluster, as I just showed you. The gravity in these is fairly loosely bound. And also, I think we now realize that the Pleiades stars were not born of this gas and dust. I think that this is like the cluster is passing through that gas and dust now. Either way, so stunning, and you quite often get lovely star glow and nebulosity within those clusters. Globular clusters are very different. They are such tightly packed balls of stars. They tend to be older, and they're located out around the halo of the Milky Way, so that they're very, very old. Most often than not tend to be quite yellow in color because they are quite old. You also notice sometimes, especially if you have thin cloud and you're looking at Orion, that the star colors will really show up, and that's not an artifact. There are actual different colors, and the hotter a star is, the bluer it is, and the cooler they are, the redder they are. So it's the opposite to the way we think of things here on Earth. And we have this spectral classification system that categorizes all of those colors, and the size differences between stars can be absolutely vast. And if this is a scale model of our solar system. So Earth is this tiny dot compared to this big sun, but our sun compared to Betelgeuse is even smaller than Earth is compared to our star. And there are other stars that are like blue hypergiants that dwarf Betelgeuse as well. So there are some really huge stars out there. And because they're different sizes and burn at different temperatures, the life expectancy is different. So the stars that are really big, like 150 times bigger than our sun, will live for around about 3 million years. And they're the ones that go supernova when they die. So they kick out a lot of power and they're very spectacular. And that power then creates heavy elements that then enriches the interstellar space, which is why we are here. Stars like our sun, very average star, will live about 10 billion years. So we're not even halfway through its life expectancy. These are the ones that will swell up to form a red giant and then shrink down into a tiny dwarf. That's the thing kids want to talk about all the time, is when the sun's going to swallow up Earth, but it's not going to happen for a long time. But really small stars can live for like 10 trillion years. So our sun is a wee whippersnapper compared to the age of those, but they're the ones that just slowly shrink and disappear without any fanfare whatsoever. How many stars are there? Well, we think there are around about 400 billion just within our galaxy. All the stars you can see with the naked eye from here on Earth are about 1,000 light years away, and within that distance anyway, I should say. And so with the telescope, obviously we're looking deeper and can see stars within other galaxies, but to the naked eye, that's what we're talking about. And we are out on one of the spiral arms. We're in a barred spiral galaxy and we are here. And so, yeah, that's amazing to me. When we see the Milky Way, we're basically seeing the results of these spiral arms. It's just so amazing. I want to talk about exoplanets because, as I said, I think it's one of the most amazing things that we're doing at the moment. And every time I do this talk, I've got to change this number because it's going up practically daily. When I first did this talk, we discovered about 600, and now we're almost 4,600, and there are others waiting to be confirmed. So the suspected candidates are actually higher than this, but this is as of the 4th of November. I checked this morning. The top methods are the transit methods, and that is where you've got a planet, we just happen to be in the right line of sight where a planet crosses the sun and it causes that tiny dip in the light curve. Radial velocity is another one we can do, which is measuring the wobble, and you heard about micro lensing earlier. So these are roughly the percentages of those methods. So obviously the transit method is favoring big stars that orbit regularly, so it's looking at stuff that's near to the star that they're in orbit around. These graphs are a little old, but the numbers are going to be very similar. But in terms of Earth radii, we tend to discover more of the ones that are around about 6 Earth radii as a priority. But by far relative masses, we've discovered the more massive planets first, obviously, because these are so far away. So it stands to reason that the ones we've discovered so far, the methods are favoring the really big ones. It doesn't mean that they're all big ones out there. It just means that's what we found, and we are going to continue to find those. I'm just going to let this video play, and hopefully you've got the sound as well, but this is a little graphic that was put together, and it's showing on a map of the entire sky where the exoplanets are that we've discovered. And you can see that by the end of the 4,000, they are just everywhere. Everywhere we look, we are seeing exoplanets. This is just the first 4,000, and these are just within the Milky Way galaxy. You can see the rates really start to ramp up as the technique gets better and the equipment gets better, the methods get better. Now it's really ramping up. You can see a cluster over here. That's basically because that's the way that that telescope was pointing. So they are everywhere, and anywhere that there's more of a concentration of one is literally just down to the fact that that's where the telescope was pointing. So initially, this is where we are, and most of the known exoplanets were out in this direction. But we also have done micro lensing that has found some of these that are heading more towards the core. This is from 2015, so we've now found more, but it just shows that's why there's that concentration of them there. The nearest one to us is 4.2 light years away, but the furthest one away, that's how big that is on this scale. And the most distant one is 13,000 light years away. But new news, you may have heard this, but on the 25th of October, they announced that the Chandra X-ray telescope had found evidence for the first ever extragalactic exoplanet. I'm not surprised, and as the techniques improve, we are going to find way more of these. But what a weird system this was. It's 28 million light years away, and it's in M51. This is my pastel sketch of M51, and it's an X-ray binary system, and it just so happened that the telescope picked this up. But it's a real kind of proof that of concept in a way that you can use X-ray to look at extragalactic exoplanets. So this is another area. Now we found one, we know that they're going to be everywhere. So another very exciting part of exoplanet research, finding all these extragalactic ones. And this is my favorite galaxy, so I'm glad that they found it there. So to finish up, what do these constellations mean to me now? They are somewhere that I go to relax. They are somewhere that I go to practice my photography skills, to just improve my observational skills. They're somewhere that I go to really test everything about the techniques that I've learned over the years and then kind of get better at the processing. But more than that, it's just somewhere that I go to escape. I'm one of those people that doesn't really like going to star parties because I like to be out there by myself, just under those stars. And I can't even explain what astronomy means to me. It's just my world, and my husband's as well. I don't mind if he comes out and joins me when I'm observing, but nothing makes me happier than just sitting out there under those stars. And for all the knowledge that we've learned today, when I look up at the night sky, I'm still seeing this little bear looking back at me, and that's always going to be the case. I am never ever going to be able to look at Ursa Major and Minor and not have this little bear's face smiling back at me. So I'll finish there. I hope you found that useful, helpful. If you've got any comments or questions, obviously I am here. And I hope you agree that some of the other mythologies are a lot nicer than the Greek ones.
Thank you very much, Mary.
So anyone else thought they could see an ATAP when they looked at Lyra?
Yeah.
You're going to now.
Definitely, yep.
Yeah, I was interested in that. I do a talk on distances in space, and Cygnus is a very good example. I've got a diagram of it I can show if I could share a screen. Just to show you what I'm. Is that possible?
Yeah, just carry on. You've got permissions.
Yeah, right. So if I can share this screen here, can you see that now?
Yep.
Oh, wow.
And the thing about that is, this is a made-up slide, but the brightest star in Cygnus is in fact furthest away, and the dimmest star, Epsilon, is closest to us.
Wow.
Epsilon is only 74 light years away, whereas the brightest star, the alpha star, is actually 1600 light years. And that, I think, is really interesting in that when you look at the constellations, not only do they look different from different directions, but this points out the fact that the pattern is just because you are seeing them in that particular direction. And that was, well, the one thing I wanted I could show you. Sorry. I'll just, you'll see that, can't you? I'll just get rid of that now if I can. Or stop share.
I think you have to stop sharing to change screen. Yeah, I found that out the hard way.
And the other thing was the Brocken spectre. I've seen and photographed Brocken spectre quite a bit. on several Scottish mountains on Ben Nevis. I haven't got the example there in Ben Nevis, but several times. Skidder's very good in the Lake District. And I came across an old article from way back in the 18th century of these people ascending the mountain, and they saw the giant of the Brocken. He was walking along and he got very annoyed about this person moving beside him, this shadow up on in the cloud beside him, and they seemed to ignore him. And this is when he was actually looking at his own shadow with the sun behind. Cloud. And I've got an image of that here. I'll just show it to the camera maybe.
They are really weird, aren't they?
I don't know if I'll just bring it near and see. This is in Little Book of Cumbria, which is a book that I published through the History Quest.
Oh yeah, I can see it.
Yeah.
And that's on Skidder, and I've got several from Skidder. That's in black and white because the book's in black and white. But the best one is the one on Ben Nevis, right at the top of Ben Nevis, looking across to the Great Red Ridge on the other side, and the mist in front of that. But those
So if your hill walking days are past you, next time it's foggy, just take your car out to a country lane and make one. It's fun.
Well, I'm 80, but I'm still hill walking.
Good on you.
The other thing, there's one other thing I have there. I don't know if I can show you. It's in a PowerPoint talk I do. I just to find the screen again. I think this is. No, it's a different one. Sorry, a big pardon. It's not on that one. I've got the wrong one. But just do a new share. It's on here somewhere because I got it out ready to look at. I think this is the one. Yeah.
It's still showing the other one. I think you have to stop share and do it again.
Can you?
Oh, there we go. Yeah.
Yeah, and this is sort of from the current slide. Oh, it stopped the share. I'm sorry, I beg your pardon. But you could see what was happening there.
Yeah, is that the proper motion of Orion?
It's the motion over many years, and the fact that things that we see now don't look anything like as it did possibly 2,000 years ago.
Yeah, give the Greeks a bit of leeway for the fact their constellations don't look anything like their characters.
Found that very interesting. Thank you. Yeah.
Just stop the share again, David.
Sorry?
Can you just stop the share again, please, David? We've all got a big blue screen.
Yeah, I'm trying to find where I am on here.
All right.
Pictures of people, and I can't find it. How do I do that? Minute. Well, I'll just, yes, actually, I think I've got it. Stop share. I've got it. Thank you. Sorry about that. Not used to doing this in the middle of a talk. Thank you.
No, that was really, really interesting talk. One question I have, that's just an astronomical naive question, I think. You said with the Hubble Space Telescope that some of the galaxies were 13.4 billion light years away in terms of age, but in terms of distance, they were 13.8 billion. Is that? What's the difference between the two figures?
Well, some of them it's just the distance they are, whereas the oldest galaxy is that age, and I think we're reaching a limit there of how far back we can go. So I think one of the slides was talking about the most distant galaxy was a certain distance away, whereas the Hubble ultra deep field is looking at stuff as it looked then, so they are all roughly that distance. I think is that what you mean? Yeah,
I think so. Yeah, so 13.4 is what most of them, and 13.8 is the farthest away.
I think so. Yeah.
Okay.
Yeah, that would be the subtle difference, because we're getting to the point where we can't really see any further back with the equipment that we have.
Right.
I mean, that Hubble ultra deep field is just crazy, isn't it? Like 26-day exposure. It's just bonkers. That
I didn't realize. I was thinking, I didn't realize how long it had taken to create that, I must admit.
Yeah, 10 years of work. It's mad.
I didn't know that. That's great to know.
They did it in 2 or 3 goes, didn't they? I think there was.
Yeah.
They used about a week's. The first one that came out wasn't nearly as good as where they've got to now.
Still mind-blowing though, isn't it? Say if I've done a nebula 3 times and I stack it, I'm like, go me, I'm a proper photographer, and it's just a long way to go.
Did you the comets you showed? You had one which was a drawing. Was that your own drawing, Mary?
Yeah. Yeah, it was Neowise last year.
Because that's what you've been showing all your own drawings, unless you say otherwise, don't you?
Yeah.
Yeah. Very good.
Thank you. Yeah, I like to try to sketch these stories where I can. Although the Rainbow Bridge and Magpie Bridge one, that's so beautiful that I love that one. I wanted to show that one.
Mm.
I think the other stories are just so much more palatable than some of the Greek epics. I find them so bad taste, a lot of them, and arrogant, and I don't know, I know that they tone them down in children's books, but the non-toned down ones are just horrible, and we shouldn't be immortalizing people in that way for doing those horrible things. So I prefer the others.
The mythical people, anyway.
Yeah, I'd rather it be named after a cash register, quite frankly.
Got a question. This again might be a silly question, but you talk about the Iroquois myth about Orion supporting the sun. And he said, in actual fact, Orion is below the sun in the summer. Is that right?
Well, he's kind of in the sky, but below the sun, or in the vague area of the sun. Just basically means he's not visible. So the story says that's where he is. But
that's what the question was. And so did the Iroquois know this in some way? That's why, because it's underneath, supporting the sun, or is that just a coincidence?
I suspect they probably knew. The amount of astronomical knowledge way back was incredible. We lost a lot of it in the interim period, but these guys were pretty knowledgeable about what was going on in the sky, and looking at those silk paintings from the Chinese astronomers. So there'll be, some of the story will be kind of just supposition based on the fact it's there and then it isn't, and they'll see that constellations are ebbing and flowing with the seasons, and they'll make a pretty decent stab at where things are when they're in the summer. It's where we get the zodiac signs from, because people knew the sun was in those constellations at that time of year. So I suspect they would have had a pretty good idea.
Okay, thanks. Yeah, great.
I love those stories where they bring in things like that, and they like the northern lights appearing and wooing the lady and then never coming back again. You just imagine that's like a kind of bright aurora display that's not normally visible from somewhere and then never comes back again.
Yeah, really that was lovely. I like that story.
Yeah. Not so good for Lindu, but
yes, yeah, it was really good.
I bet you there's lots of stories, and you had to pick and choose which ones you could do. I'm sure we could do the talk again with.
There's a really nice one from, there's a lot of, there's a guy who works at the Royal Astronomical Society from Montreal, and he's a lecturer in Quebec. And I watched a talk of his talking about Indigenous mythologies for constellations, and it was fantastic. And a lot of the Indigenous stories get lost in favor of the more modern ones. And all of them were different from the ones I knew. Every single one was different. So yeah,
there's North Americans and the Australians, of course, the Aboriginals.
Yeah, there's some really nice Aboriginal stories as well. There's just not enough time to put them all in.
Any other questions?
Yes, I thought the lecture lasted about 3 times longer than it should, and we should have had all of that put onto 3 different lectures.
Sorry, I do cram too much in, don't I? But get your money's worth. Did anyone else remember this book, by the way?
Yes.
Yes.
I've got a couple of the other old Ladybird books as well, but this was the one. When I found it on eBay, I was like, it's the book. And it's one of my most special possessions. I know it's not the original book, but yeah. Yes, John?
I don't have that, but I still have my 1964 I Spy Book of Astronomy,
Oh,
which I
nice.
started filling in when I was, I don't know what, 11.
I couldn't find my original I Spy. I bought another one sort of in the mid 60s, but I had one in the, I think, the late 50s or something.
Yeah, well, this one had a yellow cover and it cost 6p.
Yeah,
Wow.
that's right.
That's 6D, of course, not 6p.
Yeah.
Yeah.
Did you score all the points? Did you fill them all in?
Yeah, I did actually. The last thing was an eclipse of the sun.
Yeah.
Which I saw driving home from a job interview at the University of Leicester. And I thought,
Oh,
my
you
God,
mean
I've
a
got the
partial
job.
eclipse?
Yeah, partial eclipse of the sun. Yeah, I thought, my God, I've got the job. And sure enough, I did have. On a slightly different subject, but back to the constellations thing. One of our guys used the data from Hipparchus to calculate what the sky would look like on various worlds in science fiction books.
Ah.
So he was asked by a science fiction writer what the sky would actually look like on this imaginary planet Y light years away from Earth in such and such a direction. And he was able to do it by using the Gaia data to, or it would have been Hipparchus data then to figure out what the sky would look like.
Yeah.
Well, there's a lot of fake ones, aren't there? They're doing the rounds where somebody's just superimposed a Milky Way picture from Earth onto a Mars lander picture and trying to pass it off as real. And it's just, no, stop it. And everyone's like, wow, it's the Milky Way taken from Mars. Like, no, it isn't. And one of them, you can see the stellarium grid lines. I'm like, well.
I saw that, but I hadn't questioned it, but it was a fake.
There's a number of them been doing the rounds.
I've got this wee book.
Oh, I've got that. I found that one as well.
Aye, Mary Bruick.
Nice.
Which one?
Mary, it's the night.
Oh yes, that one. Yeah, that's a lovely one. Yeah.
Aye.
I bought that first because I wasn't sure if I'd got the right one, but when I saw this, I remembered the little bear smiling, and I was like, "Yep, that's the one." But I've got both of those now, which are both.
I've only got that one, but it's really nice.
Well, Stuart Atkinson, who you may know from social media, he's really obsessed with Mars, but he's written a Ladybird astronomy book for the modern day. So I really want to get a copy just so that I've got it because it looks lovely.
All right.
Children's books are brilliant. I mean, Stuart came to Border Astronomical Society as a child in Carlisle, and then he set up Cockermouth after that.
Oh, his Cat's Guide is
in Carlisle just 2 or 3 years ago.
Yeah, the Cat's Guide to the Night Sky is beautiful. It is such a beautiful book.
It's because I've got a cat as well.
Well, mine are banished, but we have 4. So yeah, they're not allowed in when I'm on Zoom.
He gives a talk usually at Scarborough every year at the Rydale Astronomical Society, the Star Festival.
He's great. I love Stu.
It's my politically incorrect contribution. This is the boys' book of astronomy.
Oh yeah,
there's a lot of them
got
around.
Its cover on as well. Mine just it's red inside the cover.
I've just been looking for the first book I got when I was sort of in my teens, and it was the Larousse Encyclopedia of Astronomy. And what strikes me about that now when I look back, I think there are only 2 or 3 pictures in the book that showed constellations in colour. And that was because of the time interval you needed to taking photographs and to get the colour. Nowadays, just about everything you see taken with modern cameras and modern telescopes, they're in colour.
Yeah. I still really like black and white nebula pictures though, when you just do like a single channel mono camera. I think they're lovely in mono.
Yeah.
I actually like the Horsehead Nebula in mono than in red.
Any other questions? No, there doesn't seem to be any other questions. I think everybody's just so impressed and stunned by the
or asleep.
I find the history of astronomy fascinating.
It was
Yeah, going
I
right.
never used to like history, but the history of astronomy really gets me. I love it. I'm so into it now. And I just used to hate history at school, but no, it's great now.
Thank you very much.
Thank you.
I think Peter's trying to get his hand up.
Right, so I think I speak for everyone tonight when I say that your talk was so interesting and emotive with the beautiful stories, especially with Lindy and all that, you know, and Lindu and all that, and the other even the one about the bear and that, you know, and the other and then the other young get made into a wee bear and put into the sky so as he didn't shoot his mother and that. I mean, they were really, I hadn't heard of some of these mythology stories before and that, you know, so it's been very interesting, and I think we've all learned something new about the constellations that we're all familiar with, you know. So I would like us to thank Mary in the usual Kaz way.
Thank you.
Good night.